Hello, I'm Tanner. This is my Git tutorial. Git is a command line tool for version control. To illustrate what version control is, I'm showing you Google Docs, which has some very powerful features for version control. Here, I'm making a new version. You can name versions in Google Docs, and as you make changes, it automatically saves to the latest version. Then you can view your history by clicking this link at the top. The text on the left is called a diff. It shows what changed between two versions. Google Docs is incredibly easy to use compared to Git, but it will not run on your local file system. Git will run on your local file system. Google Docs stores versions in a sequence, but Git stores versions in a directed acyclic graph, which is abbreviated DAG. Except that in Git they're not called versions, they're called commits. A commit is a data structure consisting of a hash. The hash is a long sequence of letters and numbers which is used to uniquely identify the commit. Hashes are often abbreviated with the first handful of characters. The hash is obtained by hashing the remaining parts of the commit. So if any part of the commit is changed, the hash will change. That includes the timestamp. So even if you copy an existing commit, the resulting commit will have a different hash since it was created at a different time. However, if you push a commit to a server, it will have the same hash on the server as on your computer since it has the same data, including the timestamp. The next part of the commit is the commit message. The commit message is a string of text written by the user when the commit is created. It may not be empty. The next part of the commit is a diff. The diff is a record of what changed between this commit and the previous commit. The next part of the commit is a timestamp. It states when the commit was created. Next, the commit has information about who created the commit, including the name and email address. Note that these are required fields in every commit. Finally, the commit has either 0, 1, or 2 pointers to previous commits. A commit with 0 commit pointers is called an initial commit. There can be at most one initial commit and a repository. A commit with 1 commit pointer is a normal commit. Most commits only have 1 commit pointer. A commit with 2 commit pointers is a merge commit. As the name implies, merge commits are created by the command git merge. A directed acyclic graph is a set of vertices, also known as nodes, and a set of edges, also known as arcs. In a Git repository, the vertices are commits. Directed means the edges have direction. Directed edges are drawn as arrows, whereas undirected edges are drawn as lines. In Git, there is division as to which direction the arrow should point. Some tools draw the arrows pointing forward in time, but the Pro Git book draws the arrows pointing in the direction that the pointers point, which is backwards in time. And some tools don't draw the arrows, but the direction is implied. GitLab and GitHub only draw arrows for merge commits, and the arrows point forward in time. In this presentation, I draw arrows pointing forward in time. That is the opposite direction of the commit pointers. Acyclic means there are no cycles in the graph. Cycles cannot occur in a Git graph since commits can only be created forward in time. In fact, Git commits are immutable and indestructible. Git made it this way to preserve history. Since commits are immutable and indestructible, you can't move commit pointers. Commands such as git commit -- amend and git rebase make copies. They don't move or modify existing commits, they only make copies. Repositories. A repository is a folder in the file system along with Git's history of that folder. The folder is called the working directory. The working directory has a child folder at its root with the title .git. The prefix dot in the name means it is hidden, and you'll need to do something special to see it. In Unix, the command ls-a will display all files and folders, including hidden ones in the current directory. This image shows the .git folder. The command git-init creates a .git folder in the current directory, initializing it as an empty repository with no commits. Do not run this command in an existing Git repository. Git config. In order to make a commit, Git needs your name and email address. It cannot send you junk. In fact, your email address does not need to be a real email address. The command git config --list prints a list of config data. The useful data here is the user info, the core.editor, and remote.origin.url, which is the URL to the server where your code is hosted. If no user info appears, the git commit command will fail. To set the user info, use the commands git config --global user.email and then in quotes your email, and very similar for the name. I underline your email and your name to indicate that you're supposed to replace those with a value. To remove things from the config list, all you need to do is add the --unset flag. Git add. The command git add file names adds all changes at the given file names to the index. The index is also known as the staging area, and it also has a lot of other names, but I use index and staging area. The act of using git add is stage. The changes are said to be staged. You are said to be staging the changes. Example, git add gettutorial.pptx. This command allows you to use regular expressions, or regexes. The only one I know is the star. The star matches any number of any characters. For example, git add star.pptx. That will add all the pptx files in the current directory. This command allows multiple files, which are passed as different command line arguments. For example, git add gettutorial.pptx, readme.md, and plan.txt. But there's more. Git add dot adds everything in the current directory that is not ignored, including previously untracked files. While the name add implies create, git add can stage create, modify, and delete operations on files. To stage a rename operation, add the file name before and the file name after. Empty folders are ignored by Git. They cannot be tracked or staged. Git status. The git status command shows in color-coded output all file names with uncommitted changes. It shows the changes between the index and the working directory in red. Those changes have to be unstaged. And it shows changes between the head commit and the index in green. Those changes are said to be staged. Let's watch a demonstration. In this demonstration, I demonstrate git status and basic use of git add. Looks like I'm creating a file with some content, and I'm going to run git status. The file is currently untracked. It's not only unstaged, it's untracked. But when I add it, I stage the file, it's seeded as a new file. Git reset with no arguments. This command unstages all stage changes. Thus, it resets the index to the head commit. In the following demonstration, I show how to stage the renaming of a file. Then I undo the add operation by running git reset. I'm going to use the mv command to rename query.txt to zxcv.txt. Now if I run git status, it has not detected the fact that I renamed the file. But if I git add the file name before and the file name after, it detects that I actually renamed the file. If I run git reset, it will undo git add. Git reset undoes git add. And as you will see, it's exactly what it was before I ran git add. The command git diff shows all unstaged changes to tracked files as a diff. Note that untracked files that are not ignored appear in red in git status, but they do not appear at all in git diff. The command git diff -- staged, which is equivalent to git diff -- cached, shows all staged changes as a diff. When untracked files are added, they become tracked, so there is no way that stage changes can appear in git status but not in git diff. In this demonstration, I will show what git diff does. I'm going to go into a subdirectory and make a change to a file in the subdirectory. I'm going to delete one line and insert one line. I'm going to exit the editor and run git diff. The deletion appears in red with a minus sign in front of it, and the insertion appears in green with a plus sign in front of it. There are two common ways to display diffs. Way number one is inline, also known as unified. This is what the diff command prints. The inline diff is easy to display in the command line. This image is from GitLab, which supports both ways to display diffs. Way number two is side-by-side, also known as split. Side-by-side diffs cannot be printed by the git command line. This image shows a side-by-side diff of the same change shown in the first image. In GitLab's side-by-side diffs, deleted code appears in red on the left and inserted code appears in green on the right. GitLab also highlights which characters changed. It is possible to get something like this in the command line using the --word-diff-regex flag. In this demonstration, I'm going to show you what git diff does about untracked files. So I make a new file. If I run git status, it appears as an untracked file. But it does not appear when I run git diff, because untracked files do not appear in git diff. In this demonstration, I will show what git diff does about binary files. I'm compiling a program into a.out, a binary executable file. As you can see, its contents are nonsense in ASCII. You would not want this to appear in your diff when you view it. So let's see what git diff does about that. Let's stage the change of creating that file and then view the staged diff. So git add a.out git diff -- staged. Binary files /dev/null and b/a.out differ. /dev/null means the file did not exist before we created it. I don't know why it says b/a.out instead of just a.out, but this is the way Git does it. So basically, whenever it can't display the diff of a file, it will just say binary files differ. The git commit command creates a new commit whose diff is all staged changes. It also opens a text editor for you to enter the commit message. This editor is given by core.editor in the config list. The git log command displays a list of commits in the history. The top commit is the most recent. In this demonstration, I start with an empty repository and I make a few commits. So you can see there are no files other than the .git folder, which is in every Git repository. And I'm creating a file. And I run git status. The file appears as an untracked file. It does not appear in git diff since it's untracked. I run git add file to stage the change of creating the file. The file now appears in git status as green. It's not appearing git diff since it's now staged. That changes stage. So this is my first commit. So I save and quit out of the editor to give the commit message to Git. Git log will show that commit, that is an initial commit. Since it has no previous commits, it's initial. I create another file. And you can see it showed up the same way in Git status. I add the file, and I make a second commit. Once again, I enter a commit message, and then I will save and quit out of my editor to give the commit message to Git. And if I run git log, it shows both commits. The most recent commit appears at the top. Branches. A branch is a named pointer to a commit. So it's a pointer and it has a name which you give it. So these are what branches look like on a commit tag. That's how I draw them anyway. Head. First of all, the keyword head is always written in all caps. Head is a pointer that may point to either a commit or a branch. Head is said to be detached if it is pointing to a commit. When the initial commit of a repository is created, one thing that happens is a branch named master is created and pointed to the initial commit. And another thing that happens is head is created and is pointed to master. The head commit is the commit given by head, whether directly or through a branch. Let's draw head on our commit tag. In this diagram, head is pointing to the branch named master. Head is not detached, but now head is detached. The head commit is the same commit as before, but head is pointing directly to it instead of pointing to master. The command getBranch lists the names of all non-hidden branches and indicates where head is pointing. The command getCheckout-b new branch name 1. Creates a new branch with the name new branch name. 2. Points the new branch to the head commit. 3. Points head to the new branch. This command works regardless of whether or not head is detached. Also, it does not involve the working directory. Git checkout without -b does involve the working directory. This command, it does not have any requirement of the working directory and does not modify the working directory. Git checkout. This command requires that there are no uncommitted changes to tracked files in the working directory. If the requirement is satisfied, then this command points the head to whatever is passed in the command line argument. Then this command modifies the working directory to match the new head commit. This is the first command we've seen that actually modifies the working directory. On this slide I have two examples of git checkout. This git checkout checks out by commit hash, so it checks out a commit and it results in head being detached. This example checks out a branch by name, and it results in head being attached to the branch. The command git reset --hard commit has no requirements of the working directory, points the current branch to the past commit. If head is detached, it points head to the past commit. Modifies the working directory to match the new head commit. All uncommitted changes to tracked files are lost. They're not stored anywhere. This slide shows 4 commands that move head. Git checkout moves head, the index, and the working directory. Git reset --soft moves head and the current branch. Git reset --mixed moves head, the current branch, and the index. And git reset --hard moves head, the current branch, the index, and the working directory. Note that --mixed is default. If you run git reset commit, it is equivalent to git reset --mixed commit. In the reset commands, if you pass a branch, it is casted to the commit to which it points. But in git checkout, if you pass a branch, the command will actually attach head to the passed branch. Of these commands, I have found that git checkout and git reset -- hard are the most useful. The reason is, if you run git reset -- soft or git reset -- mixed, then you will probably have a lot of uncommitted changes in your working directory afterward. Usually, if you want to move head, you want to move the working directory with it. Commit expressions. Commit tilde is the previous commit of the commit. Commit tilde in, where in is a number, applies tilde in times. The previous commit of a merge commit is the current change of the merge. A hash is interpreted as the commit with that hash. If a branch name is put in for a commit, it is casted to the commit to which the branch points. And there's a lot more commit syntax than that. Merging. Merging is a semi-automated way to combine changes. It's especially useful to allow people to make changes at the same time and combine the changes later. The command git merge requires one argument, the commit where the incoming change is to be found. It will then, when you run the command, merge all changes between the base and the head with the changes between the base and the incoming change, and result in a merge commit, if all goes well. Git merge is the first command we've seen that can have conflicts. The command git merge commit, where commit is a commit expression, is used to merge changes. This is not the only command that can create merge commits. Another command that can create merge commits is git pull. The command git merge commit creates a merge commit which contains all changes between the base and the path commit, as well as all changes between the base and the head. It also points the current branch to the merge commit, or head if head is detached. This is the first command we've seen that allows conflicts. If you have a conflict, resolve it in your working directory, removing all the trash git puts in your files, then stage and commit the changes to complete the merge. In this demo, I will demonstrate git merge without conflicts. I'm on a branch named myBranch. I'm going to modify a file named file. Now I'm going to stage and commit that change. This is going to be the incoming change when I merge. And it did that. Note that git branch shows which branch I'm on. Okay, I'm getting that commit hash using git log, so I can check out that commit, thus detaching from my branch. And it does this. Git branch will show that my head is detached. Now, git status shows my head is detached as well. I'm going to modify the file. Note that the change I made a second ago was undone by the git checkout command. I make a different change that will not conflict with the first one. Now, I add the file. I commit the change. This is going to be the current change when I merge. That happens. I'm going to run git merge. I'm using my branch to identify the commit to which it points. I'm going to leave the message as default, and it did this. Now if I look at the file, both changes were taken into the file. In this demo, I'm going to make a very similar merge to the merge in the last demo, except this time there will be a conflict. So I modify the, git branch will show that I'm on my branch. I modify the file. I make a change to the top of the file. I stage and commit the change. This is going to be the incoming change when I merge. I'm still on my branch. I'm going to check out the commit previous to my branch. And head tilde1. The tilde 1 means the commit before. So it's the commit before the head commit, or the previous commit to the head commit. My head is now detached as get branch show this then. This is going to conflict with the change I just made. Okay? So I'm going to stage and commit the change. This is going to be the current change when I merge. If I run git status, if I can, head is detached. Yeah, nothing to commit. Okay, git merge. My branch, I'm using my branch to refer to the commit to which it points. Conflict, all caps, conflict. That means it had a conflict, and the merge has not yet completed. It put all this trash in my file. So I'm just going to delete the trash, and then I need to stage and commit the changes to complete the merge. So I stage and commit the changes to complete the merge. And it had this default commit message that reflects what happened. Alright, look what's in the file. I just modified the file so you can know what's in it. And the command git log dash dash graph dash dash one line dash dash decorate will show the fact that it's a merge commit. Fast forwarding. Suppose that the current change is in the history of the incoming change. Then there is no need to create a merge commit to combine the changes. So Git won't create one. Instead, Git will do this. It will point the current branch to the incoming change. This is called fast forwarding. This can also be suppressed by the dash dash no dash ff flag. If you put that flag in there, it will create a merge commit anyway. The command git log dash dash graph dash dash one line dash dash decorate displays a graph in ASCII, which in my opinion is extremely useful for seeing what your commit history looks like. One little warning I just discovered. Those two commits are not actually in chronological order. The incoming change commit was actually made before the current change commit, and up is the forward in time direction. Rebasing. Rebasing is a way to combine changes besides merging. If you only use rebase and never use merge, you will not have any merge commits, so your commit DAG will be a tree instead of a DAG. The rebase command takes one parameter, a commit expression giving the new base. So if I run git rebase past, this happens. It copies the two commits from the base to head onto the past. Rebasing allows conflicts. In fact, it allows a conflict for each commit you copy. You have to resolve conflicts for each commit you copy, which can make it way harder to resolve conflicts. A lot of times, it's just impossible to rebase. The command git rebase commit finds the base between head and the commit past, and then it copies all commits between base and head onto the past commit. Now, this command can be very troublesome because conflicts are possible for each commit. That means you can resolve conflict for the first commit that it copies, and then when it tries to copy the second commit, it has another conflict. Then when it tries to copy the third commit, it has another conflict. And resolving all those conflicts is extremely difficult. If you have a conflict when running git rebase, you have two options. Option number one, use git rebase dash dash abort to restore the repository to before you ran git rebase. That includes the working directory. It will cancel the rebase action. Or resolve the conflict, stage the changes, then use git rebase dash dash continue. Now this is different from git merge, because in git merge you have to use git commit to complete the resolve of the conflict. But in rebase, you use git rebase dash dash continue, and that will complete the copy and continue to the next commit to copy. In this demonstration, I'm going to demonstrate git rebase. I'm on a branch named B. I'm going to rebase onto the commit to which the branch new base points. It had a conflict. I need to resolve the conflict in the working directory, and then stage the changes, and then not run git commit. I need to actually run git rebase such I continue. So I'm going to delete this trash that git puts in the file, and then I'm going to probably run git status, and then I'm going to add the file to stage the change, and run git rebase -- continue, not git commit. It had a conflict when trying to make the second commit. So this time, though, I'm not actually going to resolve the conflict. I'm going to look at the file, but I'm not going to try to resolve the conflict. Instead, I'm going to abort the rebase, because this is a very useful command. It's easy to get into a mess with git rebase. So I'm going to abort the rebase, and it does that. It's as if I never ran git rebase. So I'm going to try the rebase again. I'll go more quickly this time. Had a conflict with the second commit. I'm going to resolve the conflict this time. And we successfully finished the rebase. So let's see what the log looks like. So you can see that those two commits were copied. Those two commits were already there. Git rebase -I. I stands for interactive. To use the command git rebase -I commit, where commit is a commit expression, the past commit should be in the history of the head commit. If it isn't, then I don't know what happens. Now, normal rebase, you don't want to use it if the past commit is in the history of the head commit. But this one, you only want to use it if the past commit is in the history of the head commit. Otherwise, I don't know what happens. Opens core.editor. And the file will show all the commits from base to the head commit, including the head commit but not the base. You get to modify the file, and by modifying the file, you communicate with the command. Now, in some tools, it will include the base. And I know for sure that it does in JetBrains tools. So JetBrains is a company that makes really high quality editors that are not free. And if you use their products, it will include the base. They have a GUI for interactive rebasing, and it actually includes the base that you select. So it's a little bit different than the command line. You indicate what to do for each commit. And there are different things you can do. You type the word or an abbreviation of the word to indicate what to do for the commit. By default, all the commits say pick. Pick, which can be abbreviated P, means to just copy the commit. Squash, which can be abbreviated S, means to combine this commit with the commit above it. Squashing cannot cause conflicts. Squashing is the reason why people actually use this command. In this demonstration, I'm going to demonstrate rebase -I. So I'm going to show what I have on my Git graph. I have these three commits, C1, C2, C3, and we can view the diff of each of those commits using that syntax. And this is the diff of C1, and now we're going to view the diff of C2. That's the diff of C2, and now we're going to view the diff of C3. That's a diff of C3. We're going to use git rebase -I to squash those commits into one. So I select the commit before C1 and put its hash there, and I run git rebase -I, and I need to replace the lower two picks with squash. That's usually what I want to do. If you want to make it all into one commit, you make the top one be pick and all the rest be squash, which is abbreviated S. Now I'm going to make the commit message. I'm going to leave it as default. And successfully rebased and updated. Okay, my head is detached. I want to look at the git graph. You can see there's only one commit there, and it says C1. That's the first line of the commit message. To view, okay, we're going to view the diff of that commit using the syntax I used earlier. So it has all three diffs squashed into one. That's what the squash does. And here you can see the full commit message with the comments not appearing. All right, that's it. LearnGitBranching.js.org is an amazing interactive tutorial on branching. It has a lot of the commands we talked about branching, including checkout, merge, rebase, and even interactive rebase. But there are some things in Git that it does not cover, including staging, remotes, and conflicts. If you're interested in learning more about branching, this is the way to do it, since it does a really good job of illustrating what your commit DAG looks like. Ref logs. Every time an operation involving head is performed, an entry is pushed into the ref log. Git ref log shows the ref log of head. Each branch also has a ref log. Git ref log branch shows the ref log of a branch. Ref log entries are commit pointers. This image shows example output of the ref log command. So you can see that it is a list of commit pointers, and it also has descriptions of the commit at each pointer. Whenever something happens to the head, all the entries are shifted down by one. The most recent entry appears at the top. The syntax, head, @, opening curly brace, number, closing curly brace, or branch name, @, opening curly brace, number, closing curly brace, can be used as a commit expression. Remotes. Origin is the server that hosts your repository. Origin usually runs GitLab, GitHub, Bitbucket, or some other Git hosting software. Origins are free, or at least they can be. Origin and local are two independent repositories. Each one has its own commit DAG. You cannot run Git commands on the origin, but you can use a GUI. Like on GitHub or Bitbucket, you actually log in to the website and you can merge branches, you can delete branches. It's actually possible to make commits even, but you usually want to actually do your coding on your local. To make your local interact with Origin, you must use commands such as git push, git pull, and git clone. Hidden local branches. If your local branch corresponds to a remote branch, then there's a hidden local branch on your local. You can use git branch -a to see all branches, including hidden ones. This image shows that master also has a hidden branch called remotes/origin/master. That is a hidden local branch. Git push origin branch, where branch is a branch name. First of all, origin branch is optional, but the behavior is simpler with it. So git push is a valid command. This command makes remote history at the past branch look exactly like the local history at the current branch. If the past branch does not exist on the remote, it is created on the remote. If the remote branch has commits that the local branch does not, the remote rejects the push, unless the -f or --force-with-lease flag is passed. But those flags fail if the remote branch is protected. In GitLab, the default branch is protected by default. There's no merging in this command, so conflicts are not possible. Also, this command updates the hidden local branch corresponding to the current branch. Git pull. The first thing git pull does is it makes the history at the local hidden branch look exactly like the remote history at the corresponding remote branch. Then it merges the local hidden branch into the current branch, fast forwarding the current branch if possible. Since it merges, conflicts are possible. The command git clone URL creates a folder by the name of the repository, and then creates the repository in that folder, only downloading the default branch. It is possible to specify which branch is the default branch, that is, which branch is downloaded. So when you use this command, beware of security messes. In your origin, you will have the options of SSH and HTTPS. Try both of them, because I don't know why one sometimes works better than the other, but I've seen both of them work better than the other in certain cases. I don't know why. So try both of them. In this demo, I'm going to demonstrate pull, push, and clone. I'm going to create two empty folders. They're going to be called 1 and 2. Now I'm going to go into 1 and clone my repository. So this is Origin. I'm logged into it through a web browser. And I'm going to use SSH to clone my repository. So you can see that the repository was cloned. It made a folder with the repository in it. I'm going to go into 2 and clone the repository again in 2. Now I'm going to go into 1 and I'm going to make a commit. So I'm just going to edit this file and I'm going to add a new line at the bottom of the file. I'm on a branch called C. C is actually the default branch in this repository, so it was the one that was cloned. So I make a commit. And I push the commit to origin. So now the commit is on origin. I'm going into the folder called 2, and if we go into there and we look at the file, I've not yet pulled in 2, so the file does not reflect the change. But if I run git pull, now I look at the file, you can see the new line is in the file. So I'm going to create another commit on 2. I'm going to add another new line. And then I'm actually going to squash these 2 commits into one commit after I make the second commit. And I'm going to show you what happens. So I'm using git log. First of all, notice that when I use the --decorate flag, you can see the hidden branches in git log. But I'm using this to get the hash of that commit so I can squash. So I'm running git rebase -i, and I'm going to change the second one to S to squash the 2 commits into 1. And I have to make a commit message. I'm not going to leave it as default this time. I'm actually going to change it. That happens. So you can see now that there's just one commit there instead of 2. It's actually a different commit, has a different hash. So when I try to push, it fails, because the commit that is on branch C on origin is not on branch C on 2. Now, even if I use the --force-with-lease flag, it gets rejected, because C is default, so it is protected. The end. So Git is the hardest to use piece of software I've ever learned to use. That's why I made this video about Git. There's a lot more to Git than can be expressed in this video.